Welcome back, everybody. We are up to lesson 6 of Unit 3. And in this particular lesson, we're going to start talking about what types of equations have what types of solutions. Do they have real number solutions? If they do, how many do they have? So this is all based on the fact that squaring and square rooting are opposites of each other. That's something we've been talking about for a while now. To undo one, we have to do the other. That's what it means to be opposites of each other. Now, one of the things I want to make clear is that whenever you see a square root in this class, all right, it's either a positive square root or a negative square root. So, for example, if you see the square root of 9, what that really means is the positive square root of 9. All right. If they wanted the negative square root of 9, you would see negative in front of the square root. When you do plus and minus, that is only when you have to square root in order to solve an equation. So if you're square rooting in order to solve an equation, you do plus and minus. But if you're presented with a square root, it's either a positive square root or a negative square root, depending on how it's given to you. Okay. With that in mind, let's take a look at this first case here. When I have an equation where I have something squared equals a number, x squared equals a number, that is always going to have two solutions. And the reason it's going to have two solutions is, like I said a minute ago, we have to solve by square rooting both sides. So if you have to square root something in order to solve an equation, that's when you do the plus and minus, which in this case would be positive and negative 3. Okay. And the reason we do positive and negative 3 is because 3 squared is equal to 9. So 3 squared is equal to 9. And also negative 3 squared is also equal to 9. So whenever you have x squared equals a positive number, that's going to have two real number solutions. Okay. If I have the square root of something, more specifically the positive square root of x equals a positive number, so the positive square root of x equals a positive number, that's only going to have one real number solution, because in this case, we're going to solve by squaring both sides. All right, squaring is the opposite of square rooting. So in this case, x would be equal to 81 because the positive square root of 81 is equal to 9. So again, in this case, when you're presented with a square root, if there's no sign in front of it, you assume they mean the positive square root. Okay. If I have the positive square root of x equals a negative number, okay, that is not going to have a real number solution. Again, if a square root is presented to you like this, and there's no negative in front of it, you assume they want the positive square root. So an equation like this is really saying a positive square root is equal to a negative number. Okay? That is impossible. You can't have a positive square root equal to a negative number. A positive square root cannot be equal to a negative number. So in this case, this would have no solution. In fact, if you have the positive square root of x equals any negative number, it's not going to have a real number solution. So with that in mind, let's take a look at the examples for this lesson. Okay. So I have the graph of b equals the square root of a is shown below. Complete the table with the exact values and label the corresponding points on the graph with the exact values. So when a is equal to 1, the positive square root of 1 is going to be equal to 1. So when a is equal to 1, so 1 would be here, and then 1 on the b-axis would be here, so that would be labeling the point. Okay? Let me change to a different color. If a is equal to 4, that would be the positive square root of 4, which I know is 2. So 1, 2, 3, 4, and then 2 is up here. Okay. Let's change to green now. So when a is 9, this would be the positive square root of 9, which I know is 3. So 9 is going to be all the way over here. And then 3 is going to be up here. So that's going to be this point. Okay. The square root of 12. Okay, so when a is equal to 12, the square root of 12, okay, I know it has to be between 3 and 4. So when a is equal to 12, so 12 is here, okay, the square root of 12 has to be between 3 and 4. Well, if 3 is here and 4 is here, this is definitely between 3 and 4, so that's going to be this point right here. Okay. Okay, 16, so this should be the square root of 16, the positive square root of 16, which is 4. So here is a equals 16 and b equals 4 will be all the way up here. So there's your point. And then lastly, 20, so this would be the positive square root of 20. The positive square root of 20, that would have to be somewhere between 4 and 5. So 20 is over here. Here's the point on the graph. Is this between 4 and 5? Well, let's see. 4 is here and 5 is here. Is this between 4 and 5? Yes, it is. All right. So complete the table with the exact values and label the corresponding points on the graph with the exact values. We went ahead and did that. Okay. Part B. Label the point on the graph that shows the solution to square root of a equals 4. Square root of a equals 4. So square root of a, okay, if I were to solve that for a, I would have to square both sides, since squaring is the opposite of square rooting. Okay, because this squared would cancel out the square root here. So I would have a equals 4 squared, which is 16. So a would be 4 squared, which equals 16. So when a is 16, okay, the square root of a should be 4. So that's going to be this point up here that I just circled in black. Okay. C, label the point on the graph that shows the solution to square root of a equals 5. So I can once again, do the same thing here. I can do the same thing here, square both sides, and end up with a equals 5 squared, which is 25. Okay, so when a is 25, so let's go to 25. B should be equal to 5, and let's see if that does happen. It does. So that would be this point right here that I just circled again. Okay. Last one in this section. Okay, label the point on the graph that shows the solution to square root of a equals square root of 5. this is kind of an interesting case because I have square roots on both sides. I can still square both sides in order to get rid of the square roots on both sides. The only difference is going to be is that on the left-hand side here, okay, this squared will cancel out this square root, and on the right-hand side, this squared will cancel out this square root, and I'd be left with a equals 5. So when a equals 5, okay, that's going to be this point up here. That's this point right here. Now, the square root of 5 we know is not a perfect square, but we do know that should be between 2 and 3. Well, here is the point. 2 is over here. 3 is here. This point is definitely between that. So it is in the right spot. Okay? So that is it for this section here. Let's look at the next set of examples. All right, here's our next set of examples. So now we have the graph of t equals s squared. So it's a parabola. Label the points on the graph, label the point or points on the graph that show the solutions to s squared equals 25. So I have a variable squared equals a positive number. In this case, instead of squaring both sides, I would square root both sides. Okay? And this is what I was talking about before. When you have to square root in order to solve an equation, that's when you do the plus and minus. That's when you do the plus and minus. So in this case, it would be s equals plus and minus 5, positive and negative 5, because of the original equation. 5 squared is 25, and negative 5 squared is 25. So there are actually 2 points here. So when s equals positive 5, that's going to be right here. So when s equals positive 5, we can see that t equals 25, right? And when s equals negative 5, so that would be over here actually, we can see that t also equals 25. So we can see that works, okay? So that was the points that I just labeled in black. B, label the points on the graph that shows the solutions to the square root of t equals 5. So the square root of t equals 5. In this case, the positive square root of t equals 5, so I'm going to square both sides. Okay, so that's going to be t equals 25. Okay, so when t equals 25, when t equals positive 25, s is going to equal positive 5. So when t equals 25, so t, remember, is really our y-axis. So when t equals 25, s is going to equal 5. So that's going to be this point right here. So when t equals 25, s is going to be equal to 5. So that is that point that I just outlined in red there. Okay. And then C, label the points on the graph that shows the solutions to s squared equals 5. So I'm going to do this just like I did part A. So I'm going to square root both sides. And because I'm square rooting in order to solve something, I have to do the plus and minus. So this is going to be positive and negative square root of 5, which is a non-perfect square. Okay. So when S equals positive square root of 5, so positive square root of 5 would have to be somewhere between 2 and 3, because square root of 4 is 2 and square root of 9 is 3. So it would have to be somewhere in here. I would have to get t equals 5. That's actually going to be, and I'm going to use a different color. Okay, that could be this point right here. Okay, you can see this ends up being between 2 and 3, or it could be this point over here, and you can see that ends up being between -2 and -3. So there's 2 points that work with that equation there. Okay. So again, to reiterate, the point of this lesson is to determine how many real number solutions an equation has based on whether it's a variable squared, whether it's the positive or negative square root of a variable, etc. That is it for today's lesson.